Yes, hello everyone. Yeah,
Hi.
let's just wait while everybody is here.
Okay.
Hello again, everyone. Let's wait a couple more minutes while everybody connecting. I see that Maria is with us today. I'm also setting up a live stream. Hope it will be online shortly. How are you doing?
Hello, everybody. Can you hear me well?
Hi, I'm good, thank you. How are you?
We good.
Oh, good. Can you hear me well, guys?
Yes.
Yep.
Yes.
Okay. So, how is it going? How was yesterday?
Yeah, great.
Great. Did you do some cool stuff?
Yeah, actually, I did a weird experiment in addition for the plant experiment. I did it. I have a preserved butterfly, so I did it on a wing of butterfly. So the result was amazing, actually, but I lost the wing, the chloride, and so on.
Wow.
Yeah, but I took some pictures for it.
I'm really looking forward to see what you have, because from that will depend what we are doing today. So, do you already have some results right now? Did you take pictures? How is it going now? Or is it still in process?
Sorry, just 1 second. I have to remove the blur. Is it clear?
Yeah, it looks cool. Okay. So, and the rest of the team, do you have some results already now?
Yeah.
Beautiful. Okay. Super. Thank you, Hassan. And the rest, Barbara, Alexandra, Henry, Nastya, Lona, Jin Chan, the rest who's connecting, do you have results?
I have some, hello, I have some pictures. Maybe you can let me share my screen.
Yeah. So, okay, Vadim, I think, no, I'm the host, okay. So,
Yes. Can you see my screen?
yeah.
So I have some results. I tried different ones. I think this one is the most clear result because this very transparent. This one have this green part and it's quite difficult to remove it. This one too have some dark parts, and this one is just have some spots, so I think it's quite clean result too. And this one is just green. I don't know why, because I added more chemicals, but it's still green in these parts. Now that
Okay, looks cool. Super. So, maybe to start today the class, I would like to maybe begin with a short presentation, which will help you first of all to see how do you document the experiment and how can we proceed to the experiment further, digitalizing them. And let's see how far we go. Vadim, what time you start tomorrow, the workshop?
Yes, so mine will be tomorrow.
What time do you start?
As well
Same hours.
At 6, yes.
Okay. So I think you'll have some time tomorrow to work, but just think that all our parts are connected. So you will need to probably prepare for the Vadim class following this exercise that we will be doing today. So tomorrow you'll be capable to virtualize the digital experiment. So Vadim, I see that you're recording. You are not online yet, right?
Yes, I am trying to reach the person who will allow me to enable the streaming, but not now. Yeah, so I will be enabling shortly.
Okay, so let's just maybe I wait for a few seconds more when we enable the sharing before I start the lecture. Meanwhile, how's it going with everybody else? And we see that there are more people connected today. So how's it going with the rest? Do you have experiments ready? We saw some beautiful from Barbara, Sandra, from Hassan. Angel, how are you? Do you have something done?
The experiment.
Yeah. Do you have some
Yes.
results?
Yes.
Yeah. Okay. Super. Cool. Don't be shy to talk and disturb us in any moment. To cut me, ask questions. We are in super friendly atmosphere here, so just don't be worried to jump into discussion. All right. I will now start maybe sharing my screen. Do we have any people who were in our previous workshop? Well, we know Alexander quite well, but anybody else have participated in our other workshop? Probably no, no? We never met before. Okay, cool. Just to know what if I will be repeating myself, some of you or not. Okay, so I think we should see my screen already now, right? And maybe Vadim, I don't know how it's going with the streaming, but I will start.
Yeah, I think we can start. So the recording is on, by the way. So yeah, and I will try to enable the streaming shortly.
Super. So, super cool to see everybody. Thanks again for joining us. And I will start maybe talking with you about the next step of our experiment and how can we think about the experiment and what you're actually doing by trying to discover like a new property of this matter, of this materiality. And well, here I have the reference, absolutely different type of work. No, these are the experiments and large projects which are done in order to study the lead structure, in order to study the intelligence of the biological matter and be capable to transmit it into the coding. With that, what we want to say that I think now we are facing the reality when the technology is letting us to set up a direct communication with biological systems. And what we can do, we can basically learn from this system. And somehow, maybe in a more simplistic experiment, now we are not doing any automation processes. We are not doing a lot of like machine learning and not converting the DNA of the plant into the code. But still, we are thinking, how can we understand the pattern, which is basically hidden in the microscopical structure of the leaf or any other biological matter. And I will show you some other references that we were doing at the University of Pittsburgh Synthetic Landscape Lab with a colleague of mine and students of mine. And we were quite often looking and digging into the size of the matter, trying to find the intelligence of the structure. And if you look, for example, to the crystal structure, we could see and think that crystal formation, highly elliptic, the structure of the crystal, directly relates to the temperature, humidity, pollution, and basically the crystal itself is informed by the relation with the environment. And this allows us to use these properties and this through the manipulation of the material. So the design comes not from the top down, when we start shaping the form and then start to think what is the reality of that. And this term, we every time coming to the homogeneous material with simplistic performance of the matter. But here, the matter starts to be a driving force. The organizational principles of the material structure start to drive the next component. I'll pick some slides to show you maybe some references which are coming to my mind right now while I was talking. Now, in of course, we should relate all to the words of Rhino so that all architects know quite well. And Rhino was the first who started to and activity the pattern and implementing it directly to architectural design and structure. And now I really like to reframe the idea of the pattern through the word regularization. Regularization can be integration technology, and also actually funny to me now that all the anthropologists are not studying the human anymore. Anthropology studying the relation of the human and the environment. So regularization, of course, is creating the same idea that it can, which reflects the relation of the human and the environment. And within the human group, steps in ecology's mind is discussing the idea of the distributed mind. In case our mind is actually not sorry, I need to go for a second because I need to here. I'll enable, will disable, wait. I'm sorry, so yeah, and reservation is stating that our mind is basically like kept in our brain, but our mind is a system of connection to the environment, and basically it's distributed and spread throughout the environment itself. And the pattern which connects our mind to the environment is called an aesthetic. So basically, I like to maybe continue this thought and think about the aesthetic as this kind of, I don't know, aesthetic like a pattern or language which connects our aesthetic, our perception with the environment. Maybe I'm going a bit on the side from the topic of the biological creatures, but I do really think that we are observing similar patterns in different scales. Coming back to the material. So, say I was showing you before some samples with the crystal structure. Now, here I'm showing you another experiment which is called viral structure that we were developing at the Colony in Barcelona with a student of mine and with the lead professor Claudia Asquero and Carmela Zambula as well. We were working with the students who were developing the idea how can we start programming the properties of the biorock structure. Biorock is basically a system which is used for the creation of the artificial coral.
Maria,
And,
sorry.
How can we use it? Yes?
Sorry for interrupt, but we have a bit like problem with the sound. It is like very quiet with some disturbs in the background.
Okay, just 1 second. Okay, now I try to check it. So I'll mute myself. Do you hear me better now or not? Okay.
Yes,
Well,
now
I
it's
will
better.
continue. Yeah, I will also try to be maybe louder, and my microphone is here, so this should be quite okay. Second, maybe like that. It's better.
Yes, better.
Yes.
Okay, I'm sorry. Super. It's I have a new headphones and probably I kept it far from my face. So, but disturb me if stop me if you don't hear it properly. So yeah, coming back to this experiment. So basically, looking into the biorock structure, we could start thinking, how do we control the formation of this material, and through the set of experiments, start to design a larger structures. And here I want to also refer to this experiment because please look into the way how do we document the experiment. Now this slide, for example, could be a great example for you how you could study your experiments with the leaf. And basically we are introducing a catalog structure. Now a catalog where on the Z coordinates one parameter is changed. Now the parameter is contaminant, right? That we see that there is a different contaminant changing in the Z axis. Now, and in the X axis, you see that the time parameter is changed, and we see one sample which is evolving throughout the time from the left to the right. So you basically structuring your experiment in this way, it will be easier for you to communicate what is the process and what did you basically study with your experiment. So take a shot, like a screenshot, or take a shot with your mind to think about it. So, and there is another experiment with the same biorock structure where we are thinking a bit further and seeing how do we actually implement this biorock structure in for the protection of the islands in the sea, which is protecting from the rise water level. So, and here again, you see a great example of documenting the property of the material. And we're starting to understand how the strength, volume, and porosity of the material is controlled by the different compounds that we are using within the experiment. And as a result of the experiment, we could here possibly choose the best scenario which allows us to use this material in the design. Again, please take the keep this in your memory as a good example for documenting your experiment. Do you hear me well now? Yes? Like this or like that still?
Yes, yes.
Okay, super. Yeah, and as the next iteration of this experiment, as you see, we were starting to document and study all the possible scenarios of the development of the biorock structure, and finding the then running the machine learning algorithms, which is specifically cyclogan algorithm, in order to implement it to the area, in order to protect the area from the flooding. Or another intelligence that we are also studying, but is more looking into the not only material, but also the intelligence of the biological creatures. The creatures like the bees. And the bees are very intelligent builders, which are capable to build their housing with the excellent properties, ventilation, and the most efficient structure. So what we're trying to do here, we're trying to control the distribution of the material which bees are creating in order to hack the system, in order to make the design experiment. And how do we hack it? We just basically give a different scenarios for the knitting distribution, and seeing and studying how do these construct the morphology. So basically, together with a non-human agency, we are looking how can we create the new type of morphology and new type of the design iteration. So again, look at these steps now and thinking how can we document the experiment that's useful for you. Another set of material that I want to refer is the mycelium. Mycelium is a beautiful, well, this is a fungi, not a mushroom. But each mushroom has an amazing, intelligent structure under their ground, and basically this mycelium is the structure which helps not only to mushroom, not only to grow, but also to communicate, talk with other creatures in the forest, as well as send information between the different tree species and communicate, for example, information about the pollution, about the humidity or food within the soil. So it's absolutely intelligent creature. And here we are starting to think how can we use this creature in the design and how can we create bioartificial system where we are capable to control the system and by recreating this type of the 3D printed scaffolding that you see here, and where mycelium will start to inhabit the structure and build together with that. And here I think the design comes to the aesthetics of post-natural. And I think that here, looking to this image, it's absolutely fascinating how the mycelium is programming and drawing this algorithm that you see here on the each, let's say, flower, each fruit of the mushroom. And every time I show this picture, I very often have the question, but how did you draw it? How did you compute it? But I didn't compute it. No, it looks like mathematical drawing, but it's not a mathematical drawing. It's basically a nature compute instead of us. And I wanted to show you also a part of my PhD work that I'm running at the Synthetic Landscape Lab at the University of Innsbruck with Professor Claudia Pasquero. And I'm looking to the here to the wooden structure. And I'm looking into the heterogeneous properties of the wood structure and trying to convert it into the intelligent system of biosynthetic material. And if you study that basically the wood is used almost everywhere, I guess, in all countries for its ecological structural properties. It's quite aesthetical material, but the heterogeneous property that food has within its living process, we are kind of forgetting about that. But if we think about the wood, about tree, the tree during its life, it's capable to keep the load, basically keep the strength thanks to the fibers, and keep the elasticity thanks to the same fibers, and but at the same time provide the water, humidity, information, and any data throughout the full structure of the tree by the means of this vessel, which is that you see in each picture of that is a porous structure which helps with communication throughout the forest. I'm using the style gun technique in order to enlarge the database of the wooden of the depiction of the wooden section, and in order to enlarge the database and create an artificial proposition, the fake wood, but fake which is trained on the intelligence of the biological network. And I'm looking to these data sets in a different scale and a different section cut in order to be capable to compare them and to analyze it and study them from the different sections and relate the sections together. And here maybe I show you the latest results. So that's the large process that we were running through with the help of my colleague Artem Konevsky. And what I do next, I convert the latent vector of my experiment. The latent vector, just maybe if you're not familiar with machine learning, let me explain. So latent vector is basically like latent space is the space between each original image. So if you imagine that this image is original, the real one, this one is real one, and when we are starting to create like thousands of propositions between these two real images, this space, it's called latent space, the space which forms these images. And if we think that in between each point in this latent space, we could draw a vector. Now here we have a latent vector. So in this latent vector, I'm converting to the z coordinates of my three-dimensional structures and starting to rebuild and recreate this fake proposition of the material of the kind of biosynthetic wood material. And I'm thinking I'm converting it to the point cloud, vocalizing it, and creating a strategy for the biosynthetic 3D printing, which is using a wood material, but in this case, not the real wood, but a powder or the dust of wood, which we have as a waste product from our industries. How can we convert it to the 3D printing material? And here you see the strategy for the 3D printing of the fibers, but please don't look at that as the final design proposal. Look at that as the structure for the as a pathway for 3D printing. Do you have any questions so far? All good? Yeah, I see just few faces, but okay. If there is no question, I keep going. I come a bit closer to our experiment. So here we were actually running several experiments also at the University of Innsbruck with the colleagues of mine, Carbini and Enslinger and Marco Poletto. It's one of our seminars that we are doing right now, actually, in this semester, and this project by David Lang. And David is looking to the structure of the leaf and thinking how does leaf structure inform the design proposal. And what we are doing, we again take a note for the documenting, like for the documentation and the cataloging your experiment. And David is looking to the absolutely different type of the leaf structure, taking a shot like just with the photos with the camera on his phone, and I think it's kind of getting in a nice quality and starting to study it further. And the next step, we went to the scanning of the leaf. What we can basically 3D scan the leaf. And if you wish to do so, I will also share with you information how to do that. Now, so there will be a very short instruction. How could you 3D scan? It will, for that, it will be enough just to have a camera. And then with the process of photogrammetry, we are capable to reconstruct a three-dimensional mesh. And then we are coming back to this idea of the pattern. And how can we learn? How can we study? How can we think about the intelligence of the biological matter through the mathematical drawing? No? And if you look to the structure of the biological leaf, filled with all the different systems, veins, and kind of channels which are helping the leaf to provide the humidity throughout the structure. Now, how can we translate and learn it through the set of mathematical drawings? Where here we have a bit of a different logic of the pattern formation, but still it's driven by the very clear scenario and very clear rules, same as in the biological system. So basically, we are running a set of the digital experiments which help us to come to the drawing and which could be a starting point for the next design iteration. I have some other works, but maybe I would like to stop here. Maybe let me show some other drawings in the same style that basically, if we start maybe scaling up and thinking that we could also speculate on the different level, how can we, like if we think on the distribution of the pattern, on the formation of the pattern of the leaf, Now we would find a lot of logic like maybe reaction diffusion, like a Voronoi pattern. And if we zoom out and look into the landscape, we surprisingly find the same type of a pattern in that scale as well. So, and by studying the microscopical structure, can we potentially find the scenario and the logic and for the interpretation this structure in our design? And here we are, for example, coming to like scaling up this logic and thinking now about the landscape, no, instead of looking into the leaf structure. How can we, with the same techniques, redraw the landscape? And now you're currently looking to the Alps, and here by redrawing each formation and each kind of topology of the alpine landscape, we could start with a mathematical drawing, understand the slopes, understand the water flows, understand the amount of the water which comes from the melting glaciers, map the pollution, and read the landscape through the qualitative and quantitative type of the drawing. So here I stop, and I think that this will be quite suggestive for you for the next steps that we will be doing. We will come more to the experiments with the leaf, and I would like to introduce some, well, let's see how it goes, how many scripts I can show you, but maybe if we at least come from the working with the image to the working with the mesh, maybe that would be quite enough for us for today, and then we see how to proceed. So I stop sharing for now. Sorry, I have some noise here. Yeah, what do you think? Do you have any questions? Any feedback from your side? Okay, I understand. It's quite difficult to start talking, and maybe there was a lot of information, but I hope it was clear. So at this moment, maybe I will give you a little break for, I don't know, 5-10 minutes, because I would ask you to do the following. The experiment that you've done yesterday, I would need that you would download images, at least several images, the best ones, to your laptop and start, because we will start now working with them. I would also ask all of you to have Rhino open and Grasshopper installed. Now, I suggest to you that we are using Windows side of your computers for the next step. Now, so please, like, there is a few things to do. First, open Rhino, open Grasshopper, and have your images ready to work with. Who, like, have you ever worked in Grasshopper and Rhino? Maybe you can just raise the hand if you did. If you, Hassan, yes. Barbara, yes. Alexandra, yes. Angel, yes. Candy, no. The rest, Ramya, yes.
No.
Okay. Okay, so some people did not. Okay, so we will. So for that, let's have just maybe let's have 10 minutes break. Okay, and while we're having this break, basically we're using this break to bring your drawings, your photos to your computers. Just have it in one folder, open Rhino Grasshopper, and then we will start from installing some plugins to your Grasshopper site, and then we proceed with drawing. Super. So I'm here, but we talk at 10 to 7 Moscow time, 10 to whatever, wherever you are in which part of the world.
Yeah, I'm the same time in Baghdad.
Super,
Yeah.
super. Amazing. So see you in 10 minutes. So we back. Was it successful? Okay. So maybe before we start, I will ask you all to share one by one your screen and show me what you have, because for me it's important to understand which type of image you have, so if it's working or not. So I propose to start with a short review of your drawing, and also I will give you some suggestions how to evolve it, for example. Let's start with Ramya. Ramya, are you here? Okay, let's go to Alexandra in this case.
I decided to choose this one, or maybe this one, but I think this is maybe better. I don't know.
Okay. I think they're quite beautiful. Maybe I would suggest you to trim some of the kind of size when you have like, you know, this part could be trimmed, and we also need to work, guys, with a squared image. For grasshopper, it will ask you a square image. So think, how do you trim it? And go to again to the previous one. So maybe this one also could be trimmed. Do you have any option to take the image of the leaf pattern, for example, something that you might have here? I don't know if it will be possible for you or not, but I think, yeah, this would be very interesting if we, something like that, and if we could study it more precisely and really take the kind of more top view of the leaf pattern and really see how the like all the kind of beans that the leaf has. I think that would be very interesting if you have the possibility to do so. But you can maybe do it, for example, this evening, you know. But now you can take one of the pictures that you've chosen, just trim it to the square and work with one of the images. Super, thank you very much.
Thank you.
Barbara, please share with us your screen.
Yes, hello. I'm gonna share this one. Do you see my screen?
Yeah.
Okay, so this is the nasturtium leaf. So I had some problem with the cellulize this leaf. So I added the bleach in the morning, like more bleach to make it brighter. And I have so much air bubbles underneath, and I'm not sure it's gonna help in, you know, in making the pattern, because it's not so clear photo. But I think
it will be getting a bit more clear in the process when you will be taking pictures tomorrow. For example, it will be even like more clear. But now maybe what I would suggest you to do is to have a light from the back, but well, don't flash it, but maybe just the light that you have outside on the street, and maybe take some few shots of the piece. Yeah, it's beautiful actually how it's converting from the green to the transparent, and it's nice that you're documenting. Maybe take now some video, some photos where you have like more transparent background, and then you have the light. So you would study as much as possible this transparent pattern on the leaf. And I would suggest you for our experiments, try to take some zoom shots, that is like, which is basically focused on the pattern itself. Maybe while we are talking with others, maybe you could try to do that.
Okay, thank you.
So, Hassan, what do you have? I think we don't hear you, by the way. At least see the screen. I think the piece looks very beautiful, but it's also, we need to see and streamline the recording and how would you take a photo of that. I think, I show you some good examples how you could take the picture. I think it's important to have more neutral background, that it's not a kind of wooden pattern, but it's black, white, transparent, that you could think that we are trying to study the leaf. That this is really beautiful. I think that I would maybe work with this pattern. Yeah, very nice. Yeah, try to prepare a few of them, and we could work with that. But here you see that we have a more neutral background, and I think it's starting to work better. Okay, super. Thank you very much. Angel, can you also share the screen with us?
Yes, I am. Okay, now I'm sharing the screen, but I think I have to make the experiment again because the leaf doesn't make transparent, only some circles in the border. So I don't know why.
Okay. Well, Laura, you can drop a message to Laura and ask her what's happening. But maybe for today, for the experiment of today, just take a photo with your camera of the pattern of the leaf. I think you have a very beautiful pattern here, that you're very charismatic. Just take the green leaf and document it, but try to get the kind of like the least pixelated, the best quality possible for you. I'm not asking you to take a special camera. I think just the phone will be enough. But just maybe take a few seconds to take now some pictures and keep it square format that we could start working. Green is fine. If you don't have transparent, that's absolutely fine. The first was kind of show you how we could make this experiment. And that's nice, the result that you have with a transparent leaf, but for us it would be okay if we don't have a transparent, it's also really working. Super, thank you very much.
Okay.
Henry, how are you? What do you have?
Good. So I use my phone, so I cannot share my screen, but can you see this?
Yeah.
That's my image. So basically my leaf has no changes. It not become white. So I don't know why, but yeah, right now it's the image.
It's okay, but also it's just one day which passed. Maybe I think Laura was mentioning that it should take 2 days at least. But drop her a message and check it with her.
Yeah.
But same comment as to Angel. Let's take the photo, a nice photo with a high res of the leaf, of the green leaf that you have, and we work with the pattern of the leaf. Okay? Let's do it now. I give you comment. Let's start working on that. Super,
okay,
Nastya.
sure.
Thank you. Nastya, can you also share the screen with us?
Yes, 1 second. Can you see?
Yeah.
So my sample was pretty small, so it's not like there's a lot of texture here, but I can retake the photo if it is needed.
Try to take the most, well, we see just the desktop and previews of the images. We don't see a full image, but I think I understand what you have. But try to take the most clean photo of your experiment when you are kind of try to make an elevation cut, like or the section cut or elevation of your experiment. You know that you are kind of looking at from the front and taking the photo, and control what you have at the back. That you don't have a hand, that you have just a transparent background. Like maybe a light from the window will be good enough. You know that you kind of your leaf will start to shine a bit. You can see the structure of the leaf a bit better. Okay.
Thanks.
Is it clear?
Yes.
Super. So let's now work on that. Aleona.
So I actually have the same problem because my leaf looks like this and it's totally green. So maybe I need to make more closer photo, as you have said, of the structure of this leaf and work with it.
Yeah, let's try while it's converting to white. Let's take the thought. But now we can just proceed with the experiment, but you'll see that, well, basically the visual programming is the way how you could easily change certain parameters in the algorithm and change the whole outcome. So basically, by changing the image later on, you will just have a different outcome. So for now, you can take one of the image from this leaf that, yeah, just be sure that you don't have the background of your room, have it transparent, have it white, black, but neutral. Now try to catch the pattern of the leaf that we could be working with that. And then you could, for example, do certain iteration with this image, and then we go to when you have experiment done, you try the next one.
I have some comments, please, about, yeah. Actually, I did many experiments about different leaves and plants, and I think I observed the problem that why plants stay green or they convert to transparent. First of all, the thickness and the amount of the what can I say? The amount of the cells inside the leaves or the plant, as much as it's a lot of cells, it will take more time. For example, when I took the wing of the butterfly, it was so thin, so it didn't take more than minutes to change the pattern, I mean transparent pattern, while I have still some leaves, they are still green till now. So what is the solution for that? You know, there is the edge of the leaves. I felt they are protected in somehow. So when I found there are some eaten leaves by some insects or something like that, they are getting the material of a chloride and the bleach, and they are getting transparent quicker than the protected leaf. So the normal leaf will just take the material from its branch, so it will take more time. About my flower, how it became like this, because there are some edges, there are a little bit eaten or something, there was a problem with them. So I observed that it started taking the material, I mean the bleaching of the chloride from these edges, eaten edges, and also the branch edge. So in this way you can make your sample is getting more transparent in this way. Don't eat it too much. I mean, don't make it eaten too much, but try to make some trimmed edges to make it transparent as quicker as you can.
Thank you very much, Hassan, for the notes and for the comments. That's great that you have this observation. That's absolutely useful. Super.
Thanks so much.
Yeah. Great. So if Alona has it clear, what is the next step? Let's move to the next person. I don't know how to pronounce all the Chinese names. I'm really sorry. I really apologize. Jia Chuan or Huan. How do you pronounce in Chinese? Jin Chuan or Jin Huan?
Jia Xuan. You can call me Xuan.
Jia Xuan. Okay. Yeah. Sorry, I'm every time curious how to pronounce the Chinese names. I have a lot of Chinese students and I really enjoy working with them, and I'm trying to learn and understand what is the logic of the language. It's so difficult, so but I'm doing my best. So do you have some results of the experiment?
Yes. That is my leaves. Not really leaves, the flowers. Yeah. Yeah, they were like that. And I guess it's a little bit not that clear.
Yeah, I would say that the image is a bit blurred. Maybe we would need to, and there is a reflection. You know, we have a lot of reflection. Yeah, Hassan has some sharpen some filters. Yeah, that could be. So, or maybe try to take some other images. It's very important, guys, how you start documenting this experiment. And it's not only for our step, but if you saw, I'm sorry for it, and now I'm also reading your comments here in the chat. I wasn't seeing the chat. I hope that you could hear at least half of my presentation. And yeah, and you saw some of these examples of the documentation, of the catalog, all the experiments that you were doing. And this helps you to create a narrative. It helps you to study the experiment. And the documentation is one of the fundamental parts of our work. So that's very important that you maybe work a bit more on documenting your experiments, trying to understand how you catch the transparency with the image, just with a photo, and how you place the piece in the screen. Do you censor it, and how do you observe the pattern? Which background do you have? Now try to keep the background very clean, that nothing disturbs you. So try to avoid the reflection. And yeah, maybe I would now play a bit more, try to play a bit more with this documentation of the experiment. And yeah, just try now to take some other photos where we are talking. Okay, but yeah, just make it more sharp. Experiments look great, just we need to make some sharp photos.
Okay. Thank you.
Super, thank you very much. I see that also Hussein joined us. Are you here, Hussein?
Yeah, yes, I'm here. I'm sorry, I have a bad internet connection here.
That's easy. I just wanted to ask you if you have some experiments ready. Do you want to share it with us, or do you think it will be enough?
I didn't get the proper results, as there is no change in my work. Okay. I'll let you see now.
Okay. Yeah, but that could be just it didn't, like, we just had one day, for this experiment to run, so maybe tomorrow it will evolve. If not, just drop a message to Laura, and I'm sure she will give you an answer. And maybe drop a message to Hassan. He also observed some good points, and he it helps us a lot. So
Thank you.
yeah, if you don't if you
can
don't
check.
have
I
a
didn't
result
have
now,
the
okay,
change
okay.
is very slow in the leaf.
Yeah, that's normal. So maybe if you start setting up a strategy for the documentation now, it would be nice. Start to take photos of the experiment in the green state and try to make a photo with a neutral background, have a light at the back, and try to take a picture which is, well, express the
Yes,
pattern,
I did it.
formation of the
I did it,
pattern
but
of the leaf.
I didn't get any further change in the leaf, so I was disappointed
Okay.
with the results.
Well, it will start working. Don't worry. For now, you can take the photo of the green leaf in order to catch up now with the class of today. Take a photo of the green leaf, of the same that you have now. It's just think how you document it. Position and central, and let me just again my screen. So I will go again to some documentation. Just one second. Okay, you have it, right? So, like for example, it's quite an easy thing to do from one side, but then I think that this is the crystal structure, but taken with a microscope. But this is just a photo camera, but this is ice. And how you take the photo and how you kind of create a language for the communication of the experiment is absolutely important. Then there is another experiment that we are doing, and again, it's just a photo with a simple camera. And when we are starting to, for example, study how the experiment evolves, it's important to start creating a language, to communicate the different steps. So, for example, you could start taking a photo of the green leaf and then study it while it's changing. But then you are taking picture every time from the same point of view and documenting the step-by-step the evolution of the experiment. Giving you again some other examples of documenting. You just saw it's my presentation. I just again wanted to underline an experiment basically with the leaf. Also think how you document, and see that it starts to make you to make a presentation, that starts to make a discussion. Think that everything what you are doing, you would need to bring into the design process. And in order to bring it into the design process, you would need to find a way how to communicate it, how to read it, how to process it. So these are some examples how to work that. And did you see that we don't have much text here? We never put a lot of text, but we have a very small index saying which type of leaf is that, what is the size, what is the scale. You can take, for example, like little notes which are informing the viewer about the material that you are working with. And here, next comes the drawing. So start taking some pictures now. I think we need a photo, otherwise you won't be capable to follow up. Should we work on the photos right now for another 15 minutes? And then you upload it back to your computer, okay? And we start with the exercise. Because I need a photo from you, at least one. Maybe then you will experiment more. So, okay, 10 minutes. Let's have 10 minutes. Okay?
Can I ask you?
Yeah, sure.
1 second. I wanted to ask, is it better to have black and white image or as a original one?
Up to you. Both will work. I like both of them. And the original actually more.
Okay, thank you.
Super. Great. So I give it other 10 minutes, and then we go for the grasshopper for sure. Good. Cool. So it's 7:30 or 7:30 whatever. In 10 minutes we start.
Maria, sorry, could I ask you?
Sure.
I've taken another photo. Do you think it's better?
Yeah, maybe try to zoom. What if we start seeing the structure now itself? Yeah. What if like, but you see, by just zooming won't work. But here you have very beautiful patterns. No, if you start observing it, that's what would be interesting to start seeing all the small kind of details of the sleep. That's what would be interesting to discover. So try to kind of maybe take some other photos. I think if you have just transparent background, it will work better. Like not the background of the image, but when you take a photo, if you have a chance to hold it in the hand and just have the light as the background, not flashing light, that you still can take a picture, but then you will see in the transparency, you will see a structure of the leaf.
All right, I'll try one more.
But it's getting very good, going in a good direction. Okay. Oh, I wait for you.
Sorry, just one question.
Yes.
Yeah, actually, do we need to crop the image to square percentage proportion? I mean.
Yeah. Square.
Okay. Yeah, because I just
Like,
checked the definition. Yeah.
yeah.
Thank you.
Can the part of the picture be without a focus? Okay, maybe I can show you my. This is okay, or should I try to do it more focused?
Should we have it more like this, like having this part of the leaf, but this trim this one?
Okay, but it's not in focus.
Right.
It is okay, or should I?
It's okay. Keep it without the focus.
Thank you.
Yeah. Okay, so we would need to continue. I hope that you all managed to take some photos. All good? Yeah, super. Barbara, Hassan, good. Alexandra, Angel, cool. Henry, yeah, cool. Nasta, Lona, silence, still. Jin Chuan, Ji Chuan, no, Ji Chuan, Jia Chan. Difficult
Yeah.
still. Okay, Hussein, Ramya, you managed to take some photos? Okay, I hope so, that you could all continue, but that's fine if there is some problems now. You could continue further, developing the documentation process and the rerun algorithm again. Remember that we are recording everything, that you will be capable to go through the exercise once more. So, but let's start, that we don't go to the night with our experiments. I want to introduce you some steps. Here in the chat, I sent you like a folder. I'll resend it once again. So in this folder, I share my screen. I will share all my screens so you see everything. You see here in this Google Drive folder, I prepared for you 2 algorithms. Maybe let's try now with one and see how it goes. If we are fast, we can see the second one. If not, but let's see which results do we have. Maybe we look at that tomorrow if Vadim will allow us, or let's see the speed. So I will ask you to download the algorithm which is called Displacer UZ00. Okay, for that algorithm, you don't need Firefly, so far you don't need to install it. Firefly plugin needs for edge detection, so for the net algorithm. So let's download the Displacer. Then when you download the Displacer, it will appear in your download folder. You need to open Rhino. Rhino has very primitive and easy for any designer, architect, or an artist interface, because I think it's very similar and intuitive, like intuitively driven, and it's similar to Maya, Rhino 3ds, or 3ds Max, sorry, and Blender and all other software, which all of us are usually using for 3D visualization, for animation, for 3D modeling. So if you have never used, or even it kind of have the same logic as AutoCAD, but of course it's not absolutely the same. So, and if you've never used Rhino, you could see like basically the common interface, where here in the command you could type the command, for example, I don't know, a box, and here you will have the coordinate system that will help you to have your objects in the right scale and the right proportion. You can every time just draw the box, or you can every time, for example, take the surface for points and control the creation of the surface, starting from, you can, for example, you see that here you could, it's asking you the first corner of the surface. You can put the point here, or you can type 0, 0, 0, and you are sure that you are starting in a 0 coordinate. Then you could randomly place the point here, or you can type, for example, 1000, in order to have the point in the distance of 1000, 1000, and for example, 1000. And that will allow you to have a surface starting from the 0.0, and having the surface the screen. Remember that you could switch to the different positions just by double clicking windows or by navigating yourself here. You can also be switching to the different ways of presenting of representation, from the wireframe to the shaded or to the rendered. Now, and if you are going to the rendered one, well, now here it's just on the white background. Wireframe is the lightest way to present your surface, and the rendered, of course, is the heaviest because it needs to process the data and the light and kind of re-render the visualization. So I don't really want to go in explaining the Rhino interface, because I think you could manage to do it yourself, or if you want to study, you could, like those of you who never use it, you can just open the basic tutorial and like you will discover how to use it quite fast. So, but I want to introduce you some Grasshopper scripts. So, to start the Grasshopper plugin here, you just need to type Grasshopper and press enter, and Grasshopper will be opened here to the next window. So basically, Grasshopper is the plugin for Rhino, which allows us to create the mathematical drawings, to create a parametric instrument for Rhino. You following? All good? Yes? Yes, super. To start, now you could go to the in Grasshopper file, open the document, and where you save the algorithm, you just select it, and it will start popping up. Well, I already have it open, it will drop here. Or you can just open your folder, your Windows folder. Sorry, I'm in the parallel and it's a bit messy. And you can just drag and drop it here, and it will be also open. So when you open it, I don't know, like in a Grasshopper, you have here a lot of plugins which are enlarging the database of the of Grasshopper. I don't know who has what installed, so it's probably for some of you, some components won't be working. But before installing all the stuff, I will ask you to open the algorithm and tell me what it says. It doesn't give you any problem in saying, hey, I'm missing some files. Please do it and tell me who is missing which plugin.
Mine is okay. It's very well.
Okay. I couldn't hear. I don't know if you were talking. Could you just repeat?
So everything is okay.
Okay, super. The rest of the team, how's it going for you? Just
mine's good too.
Super, Henry. Great. Let's go one by one. That all of you have it. Barbara, how's it going for you? Just you can drag it here like this.
Yeah, I know. I'm missing one component. It's a multiplication.
Okay.
Maybe I have the old version and it has to be here. Okay. So I will connect it. It's fine.
So try to do that. Double click here and type.
Yeah, I know.
Multiplication. Super. So and you will have it. Super. The rest. How's it going?
I guess I missed one of them. Is on the right top, the big one. PU with yes.
Match from points. Yes. Okay, that's fine. But you are missing a plugin mesh edit. Some of the components here are missing. But we are fine. You will just you'll be capable to make a mesh. But since some of you said to have this problem, to start downloading the plugin, and you can, like, basically all the plugins are working with different stuff. Some of them is point clouds, others is physics, Kangaroo is amazing stuff. So, for example, apply to architecture, Tarsier and Polvox, point clouds. I'm working with that actually quite a lot. So, but if you, for example, go here to your internet, and you just need to type mesh edit grasshopper download, and here you have food for Rhino automatically pops up, and here you have this mesh edit component that you can download. It's usually done for some years back, and done for Rhino or for Grasshopper 5 or 4, but whatever version you have, try to install it. I think it will work. So basically, it's absolutely for free. You can just press download. It will ask you to log in, lead you to the page for logging in. I have an account. If you don't have an account, just make the account with your email. It's absolutely for free. They don't spam you. It's absolutely nice. So just make the account, log in, and then it will allow you to download it for free. When you will be installing the plugin for Grasshopper, that's important information for everyone who have never used the Grasshopper. There are two options to install the plugin. Sometimes, for example, as sometimes you will have, for example, this file that you see in the screen, Firefly installer. This one will ask you to, because it's like file for an installation, it will ask you to double click and run a common installation procedure, pressing OK, given the direction where to save it, etc. Then you will just restart Rhino and Grasshopper and it's done. Some other files, like for example here, you will see that, for example, Firefly installation. This folder, it has this different files, and they are basically installing the plugin. But in this case, you don't have installation file. You need to copy them all, copy them, close this folder, and go to your Grasshopper folder, go to the file, go to the special folder, go to the component folder, open it, and paste it here. So basically, you're here entering the folder called library. And you're pasting it here. After that, closing it, you're closing Grasshopper, you're closing Rhino, so you're closing all windows, and you restart again Rhino and Grasshopper. And this component should show up you here. So you'll have it, and you'll see that this component won't be missing anymore. So that's the way how you install the majority of all this Grasshopper plugins. And just remember, those of you who've never done it, how to do this. So yeah, if we are good, if everybody have opened the definition, if nobody has any questions, we can start working. No? Yeah, can we? Okay, nobody is screaming no, so I think I can start. So look, we are doing super easy things which allow you to translate this image to the three-dimensional representation. So basically, to do so, well, you don't have a result yet because nothing is working for me. We will work with a surface. I've just explained you how to make a surface here in Rhino. You can type surface or go to the surface from 3 4 corners. And let's agree that we are, for example, working, type in Rhino units, and you will have this folder, or this window popping up, and choose millimeters. I think that we should work in millimeters. I don't know what, if we will need to rescale it for Vadim. It's okay, we will do it later on, but now we will be working in millimeters. You can see that you can choose different units to work with. And but usually when you are doing some kind of a tiny design piece, you will work in millimeters, because then you will need to consider that you are preparing a model that, for example, you want to send for 3D printing. And in 3D printing, you will need to control the resolution of this model until like the millimeter, even half a millimeter, to be capable to print. So let's go to the millimeters, choose the millimeters, press OK, and we are good. So now we are sure that we're working in millimeters. So if we are taking the, let's just do it again. Now, if we are going to the surface for points, we want to start in 0, 0, 0. Then we want to have 1000 on one side. It's starting to draw you a point. If you press Shift, it will go just to the X and Y axis. So it will be easier for you to control the geometry. You press click when you are. Should I have? Sorry, do it again. So at my first point, I put 1000. I have a second point. I put 1000. Pressing Shift, I have a third point, and I type again 1000, and I have another point. Here I have my surface, and it's 1000 by 1000 by 1000 millimeters. I know it for sure, and we can work with that. So if you have also, there is in Rhino different settings how you can control, the properties of the viewpoint. You can go to the viewpoint properties. If you, for example, annoyed by the grid or your color of the background you don't like and it's annoying for you, just go to the to the display options. Sorry, go to the appearance, colors, and here you can control all the different colors, hide them, and do any modifications if you so. But I just don't care, so I keep it for now like that. So this surface we need it in order to connect Rhino and Grasshopper. Actually, I didn't ask you what is the level of Grasshopper from everyone. Maybe I'm explaining some basic stuff that you all know and will teach me now how to do it better. But if it's too primitive, also tell me, and feel free to interact and correct me or do something. But I will be kind of explaining everything from zero, from scratch, because some of us are working the first time. So basically, in order to start working and linking Rhino and Grasshopper, what we do, we have here the component surface or mesh. We are working with the surface. So to make this component surface, you can just type surface and select it from the list. Or you can find this component here. For example, in surface, you will find a component surface, or in mesh, you'll find a component mesh. But basically, when you know what you want, you just type surface, and that's this component. And if you right click, you can say set one surface, and if you have in Rhino the surface selected, it directly attached here. And if we basically go here to the layers in Rhino and hide this layer in Rhino, in Rhino we don't have anything else because it's hidden, but we have it in Grasshopper. So now what we need to do, we want now to set up a coordinate system. Now we want to set up a grid that will help us to work with this surface, because basically we need to have a certain kind of matrix to navigate and translate the surface. So this is this component which will help us just to make a square grid. But it asks us the point because it doesn't know where to start. You can put here 0.000, or you can do just the following. Okay, let's unhide our surface. Let's take the point. Let's put it in our, or let's just 000 is here. But this point in our definition, I will explain you later why, needs to be a bit lower. So if you don't have this arrow lightening, you can just press here gumball, it's opening and closing. You can just drag it on the Z axis to be down, Or you can do differently. You can type -10 here, and it will just be in a position -10 under my surface. So I have this point, I have selected it, and I can press to the point component in my grasshopper, set one point, selecting it, and now it will start recreating grid. Let me just close this one. So basically, if I had here the surface, now I need to have a grid under the surface. I don't know which other parameter do you have there saved. I just don't remember. But we would need to understand what is the size of the grid. No? Now I adjusted that the grid is exactly under my surface, but probably you don't have it the same because these parameters are different. And if you see here, I also have it written that first slider, which comes here, it tells you the size of the frame. And the second one gives you the resolution. And if you change the parameters of this slider, now you will see that the proportion and the density of the grid is changing. If you are making the grid which is too dense, you have too many points for calculation. It means that the computer will be struggling to calculate. But if your grid is too, kind of the resolution of the grid is too low, then it will be basically not giving you enough of the good results because the resolution will be too low. Now I just put a higher res of my grid, and you see that now the scale of my cell is super small. So basically, in this 1000 by 1000, my grid is absolutely dense. Let's see if my computer will handle it. I have here a grid. I don't know. Maybe I will stop now, and I will need to restart. Let's see. Usually, I would suggest you to have 1000 here and maybe 200 here. Okay. So I will work in a high res. You'll work here. Just double click and put 200. Okay. So maybe look. You also have a chance to modify the slider if you've never done so. Here you have a minimum and a maximum range. So maximum range, that the slider works with this kind of maximum number. So maybe you have here lower, put 1000 if you need so, in order to make the value change in one slider higher. So yeah, and see that my computer is not responding, and also I'm working in a parallel, so it's not directly Windows. I'm working from Mac through the parallel window, so it's going to be a bit slower. So, and basically in each of these square, you have a corners, and you see that in each corner you have a point. And I want to project this point now on my surface, because basically this is the grid and my surface is still here. And I need now to subdivide this with my grid. And here I have this component, which is calling project points. And what it does, it takes the list of the points from here, and it's flattened and it reorganizes coherent list, and plugging it to the my projection component. It's also asking me the direction, and I'm saying it's Z. And if it's positive Z, so basically that is by default positive, it's just projecting up. If it's negative, it's projecting down. And I'm asking the geometry, and my geometry to project on is my surface. So basically, it takes this list of points on a Z coordinate, and we remember that our point is below, so, and it's the starting point of this grid, and it's projecting each point of the grid to the geometry that we gave. like that, we are creating this kind of projected mesh. Oh, I feel that I won't manage, my computer won't manage with this amount of points, but let's see. And in order to work further with this algorithm, I'm rebuilding and reconstructing another surface from the same point. So basically, I'm preparing a set of coordinates to work further with. So now let's see if it will start working. I will need a few seconds for the calculation. Okay, well, it's thinking. I will see your faces. All is working for you guys?
Yeah, I have the result. I actually, but the height is a little bit high.
Okay, okay.
Can I?
Now we come to that.
Can I share my screen?
Let me maybe
Okay.
continue. I will just show to the guys, and then we start sharing the screen and we show. So here we are basically rebuilding the mesh and dividing this mesh back to the same surface. It's a bit redundant, but basically we're trying to organize the set of the points in order to be capable to work with. So now we have this grid that we will be we will be giving to each of the points, we will be giving information from your image, how to process, where to locate. And this component called image sampler, you can double click on that and give a path to your image that you've selected, check one. And that's why you need a square, because basically it needs to fit the square grid that you've created, and just be sure that it's square. You're selecting the image that you're working. I've selected this one that you have here. It's just, I didn't do the experiment with Laura yesterday, so it's just a plant from my home, and I took it to my iPhone, and here it is. So, and I upload it here. So again, you just press here, you choose, you press open, and you have it here. So have it 0 to 1 to still fit it fully to the page. Don't have it as a tile, because here if you press, you'll have a tile, and press it. So basically now this image is plugged into my algorithm, and you see my co-processor is processing. Remember that I'm working with much higher amount of points than you in order to show you some cool results. A few seconds more. Give it another chance. Getting there. Okay. Sorry. Thinking. Okay, I think that's a good sign. So then next component, the graph mapper, is remap the values of the highest and the lowest points, or the brightest and the less bright points from this image to the structure of the numbers. We are giving here a domain. So basically, these numbers are setting up the domain, and basically asking to work in this domain and assigning to each point the position in the Z coordinate. We are using multiplication in order to define the scale. And I have 100. Let's see how it comes now. So basically, next step, ask to create a line, a vertical line, because here I have a Z coordinate, from every of these points that we've created in a Z coordinate, asking to create a line with the distance that we structured here. And you see that I'm starting to have a high like density structure, which is starting to have this kind of morphology. It's not very visible. Then each of these lines has the highest and the lowest points. Now it's selecting them all. This component gives you an outcome. This is the lowest point, this is the highest point. So basically, the highest points are here. You see that I'm having this suite of points that create the surface. This component just rebuilding. Sorry, I'm thinking this. Rebuilding the surface or mesh out of those points. And you see that this morphology is starting to have a similar like structure that we had before. So now what we could do in order to bring it back to Rhino, now we could just bake back to Rhino to another layer, second layer, for example, the surface, wait 2 seconds. And here we are starting to have quite an interesting topography taken from the image. And to succeed and make a beautiful experiment out of this step, basically you need to control a few things: the quality of the image and the amount of points. As you see, the points that I was giving to my mesh is, well, they're quite dense. Now press save, just have it, call it digital V, but not PDF, but that. And I save it in our folder to myself. But save it, but we don't lose this file. It's very important that when we bake, we have a lot of data. We worked on that quite a lot, and you save it. Think that when you are saving Rhino, your grasshopper is not saved automatically. And if you want to save all the iterations and change values of your algorithm, go in grasshopper file, save documents. It will remember now all your changes. So, and think that if you have here even higher amount of points in the resolution, then you might have even better quality. If you have a better image than I do have, because I almost don't have a good resolution of the structure of the leaf. I have certain cracks, but if you run your experiment and you will have all this beautiful transparency, different types of patterns will start to be readable. I think it might be absolutely beautiful. And then also the scale here. If you're like, if you have here the scale of, I don't know, scaling this up, let's put the maximum example 500. I will try to kill my computer to help you, to show you the possibility of evolving the structure. For example, I want to hide this. And what if now I have this type of structure, but for example, what if I multiply it by 500? Now it needs to think a bit, because you remember that I have a lot of data to process. So it's basically calculating each point, each line for me. And now I have this highly exaggerated topography, which probably you don't need to have that, but you can experiment. Maybe some of you want to develop something different. I don't know, some experiments with height, and also could be cool. Sorry, frozen. So actually, I like it. Very, very interesting. So yeah, no, should be, for example, take this mesh layer.
Actually, I still have the height problem.
Which number do you have here?
Yeah, I've changed it from 100 to 0.3 and it's still the same.
It's the same. You know what? I think it's just it just remembers, like the helper basically, it remembers its old values sometimes. And
okay.
Do the following. Maybe move this point a bit more down.
Okay.
And reassign it here. This will let, like, it's just whatever. You do some manipulation and asking the algorithm to recalculate each step again. And it will start recalculating and resetting it up, and I'm sure this bug will stop bothering you. Try to do that.
Yeah, I'm trying, just it's calculating, I guess, but the result, I just move the point by gimbal, everything like undefined. Can I share my screen?
Okay, just a second.
Oh, okay.
Okay, show it to me.
Yeah, can you see it? Okay, this is unneeded. I'm sorry. Yeah, I'll do it here. It will redefine everything and Can you see the result? I don't know why it's like this while the pattern is different. While I can see something from the pattern here, but I don't know. And the height is still like this. Yeah, I don't understand why.
What is the size of your surface?
Yeah, 1000 millimeters.
1000. Okay.
And here it's 1200. Okay, here.
Go to the, put, like, for example, 200.
Okay, this is 100. Is that okay?
Yeah, okay.
Now let's start recalculating.
Is it baked or not?
No, it's still the same. I feel it's like, I don't know.
But
the inner
did you
and
bake it?
No, I didn't bake it. This is just I turn on the preview.
Okay, can you press now the
bake
from point? No, don't bake it. Okay. Go to the image sampler.
Okay.
Double click on that.
I will choose another one. Like, I don't know, this. It's not responding. Yeah, it's calculating. Yeah, it's the same.
Okay, yeah, it's just remember some qualities of that. So can you enlarge a bit your stream of Grasshopper?
Okay, sure.
Just maybe go full screen of your Grasshopper.
Yeah, this one.
Press the line. I will press here and preview it.
Okay.
And let's see what it shows you.
Yeah, this is the vectors.
Okay, so
I think the height is here is defined something.
no, but should we? It's something that keeps the memory of the previous, I think, of the previous iterations that you've done, and doesn't structure it. Double click to the image sampler now.
Okay.
Okay. One. Tiling. Go to the tiling. Like a bit below. Okay. Okay. Press OK.
Oh.
Trying to shake it a bit to see what it changes. And can you turn off the preview of everything? Just make a preview of the current step. You can control it.
It's loading now. Yeah. Yeah, same.
Okay, so you can control this here. Make the preview option just like here.
Okay.
You can control the preview option. Just make the preview of the current step, but not of the old step.
This one?
Yep.
Okay.
Okay, now press the line. Let's redo multiplication. So just type multiplication here and connect these numbers. Like double click and type multiplication. I think you're working in the right scale. What's wrong? And reconnect it.
Yeah. Same.
Am I not seeing what's happening? This one. You have it. I don't know. Well, we need to check maybe with you individually. Can you pass me your algorithm and your image? Just send it to me through the email. I will open it on my screen, share it now with the screen, and I will kind of check it together.
Okay.
Because
thank you so much.
It's a bit difficult to do it like that. We will check this now. Super. So
I had the same issue. Changing the scale of the Rhino, checking the units of the Rhino helped. So when I changed it back to millimeter objects, the lines, like the heights adjusted properly. maybe you could just reboot your Rhino and then open it with a millimeter scale. That could help.
Yeah, but we should work in millimeters. You guys working in millimeters? Yeah, choose the millimeters for your Rhino. I was thinking that you're working in millimeters.
Yeah, I was working on centimeter, then I changed it. So I guess from the opening, I should work from the beginning on millimeter, right?
Go to the millimeters.
Yeah. I want to stop sharing. I'm lost. What? How can I stop sharing? Can you stop sharing from you, please? I mean.
Second.
Oh yeah, I found it. Yeah, thank you.
Super. Oh, we just a few people. So many people got lost. So how's going the rest of the team? Did you manage to do that? Barbara?
Okay. No, I have some issues, and I don't know where is the problem. Like the component on the end of like surface from points doesn't work. It says that the points in the grid is null, so there is no points in the grid. I don't know why.
Okay. Okay. Share your screen.
Okay. Sharing.
And this issue, many of you will have it for sure.
Okay. I don't know why it's super small. Like here, I have my surface, and it's 1000 by 1000. And I set it for here. Yeah, and it goes to the project points. And here's one.
I think you're also working in. Are you working in millimeter?
Yeah. Yes.
And your mesh is in millimeters?
It should be, no?
Like the surface that you created here is it in? I'm not sure that it's 1000 by 1000. Just grasshopper shows.
I will show you. Yeah.
Okay. Or you can type distance, then it will show you the distance in the command.
In the command?
Yeah, like type distance, and do the same, but then it will, in the command line, it will show you the distance.
Really? No, it doesn't. Okay, but it's here. See? On the right. That's the.
Somehow maybe it got frozen. I don't.
Yes, I will throw it. Yeah. No, yeah, it's the same.
If you, I don't know, somehow your sharing got frozen. Okay, it's now fine.
It's okay. So I will do the same. Just set.
Okay. I see that you have. Yeah. Yeah. Your surface is 1000. It's just here. You have 100, so that's why it's so small. Yeah. It's here 1000.
Okay, so it's gonna go.
We see your Internet Explorer. Okay, so let's see what you have now. Go to grasshopper. That's all good. Good grasshopper. Okay, good, very good.
And this is the same.
Okay, does it tilt you the surface out of plane? Like the component?
Component?
Go to the right.
Okay.
More right.
More right.
Surface from point. This one. Does it create you anything?
No. It doesn't
so
show
check.
anything.
We need to see where do you have an error. Does it create your line? Try to navigate us through the definition.
I don't have any.
Here is null.
Yeah, there's no, but I have values, so here.
Okay, so maybe the problem comes where you upload the surface, the image.
Mm-hmm.
Just 1 second, cancel for now. Can we do the following? Can we do this?
Actually, I've solved it.
Yeah,
result is great.
What was your problem?
Yeah, actually, I found out that my point was on the 0, 0 coordinate, so I moved it just to the down. So I got the result. Can I share my screen now?
Yeah, do it. While Barbara is finishing this thing, probably her computer is calculating, but I'm sure that now it will be working for you as well. But you have 500 resolution, that's why it takes time, Barbara, for you to calculate. Okay.
Can you see?
Yeah, I see. Beautiful.
Let me see. That's good.
Okay.
Let me increase the result.
Super. So we've got some coolness. That's great.
Okay. I will stop now.
Okay. Okay, so Barbara, does it work for you now?
Nope.
Okay, share the screen back.
Do you want me to share screen?
Yeah.
Okay. Yeah. I will do this. No. So I don't know why.
So yeah, because let's look at. Hold on.
Do you see the mistake?
Go. Yeah. Stop here. Stop here. Hold on.
Yeah.
Zoom out a bit. Zoom out a bit. No. Go there.
Okay, so I will just zoom out. Yeah.
A bit more right.
Right.
Okay. Stop here. Enlarge the screen of Grasshopper, please.
Yeah, sure.
Yeah, or just stop now. Don't do anything. Yeah, super. So you need to give the data from here, from this component, to our image sampler. And specifically, you need to give the data, from UV towards here. This is the data that you need to have. So now it will start calculating.
Now magic
We
is
again have your Google Translate open.
my Google Translate?
Yeah, somehow, because probably when Rhino is starting to think, it closed the screen for us, and we're starting to have something.
Okay.
Just let you know. Okay, now it's probably calculating because there is a lot of data.
Okay, wait. I will try to do that. Now I have 2 red on the end.
And you need to remove this one.
Okay.
Remove it. So basically, this C in the component of the square grid is, if I'm not mistaken, gives you cells. So, and you need to work with points. Okay, now check how it's going.
Interesting.
Okay, so that's fine. That's fine. That's also something that happened. Now let's see the image that you have.
I have this
in the image sampler. Double click on the image sampler. Okay, can you right here and go 0 to 1? Maybe it will give you the one mistake.
Yeah. I have something. Yeah, it works.
Okay.
Nice, thank you. Yeah, so what does it mean, like the X and Y dimension in the picture, in the image?
Yeah, now actually show us your surface. I think it's beautiful.
Okay, wait.
I think it's very good result.
Now it's calculating
very
again.
nice. Okay. So, I think for Barbara everything works perfectly.
Thank you.
You could, yeah, you could experiment more, see how things are working for you. I think that today I see the timing that we won't have the chance to work with one more definition, but you already have it in the Google Drive folder, and this algorithm helps you to detect the edges of the images. You can also check it just home. It's super simple. You will basically need to do the same thing. Now that I won't ask you to do it yourself, but I will just maybe very briefly show it to you. 1 second. I open it on my computer. So we will check with the rest of the team as well how it's working for you. But I just wanted to show you that you have also another work, like another algorithm here. To do so, to run it, you will need also to install. Here you have the installation link. Go here and install the Firefly experiment, and you can install the Firefly fluid as well by copying all the files, same as I showed you at the beginning, and then it will install Firefly, which will help you with this edge trajectories algorithm. And when you will open it, you will see this beautiful set of components, and basically the steps are quite easy. If you go here, this component gives the path to the file, and the file is the image. You want to take one of the images, let's take the same one, open the file, and you will need to calculate it a bit, and basically it starts appearing here. It's quite a time consuming. Why? This sorry. So it's basically starting to draw you in the proportion of your image, starting to red draw this algorithm, the trajectories, the edges of this image. And you can have here the control by setting up the number, the seconds, which is calculating this algorithm, or stopping it, or freezing. In order to start working with this, for example, drawing, you could go to the last component, which is rebuilding. So here we are just pulling. Sorry, it's heavy. That's why it's getting so slow. Sorry. So this component, the last one, is basically reshaping all this pattern and cooling out. The previous steps are cooling out the doubling curvatures and like reframing them in a solid line. If you double click this component and bake it, you will have this image on your Rhino. No, bake it. Then you could be using this curve as well in your drawing. So please also check this. Stop sharing, sorry, because it's super slow, and I just need to disconnect because Bloom together with the grasshopper getting crazy. 1 second. Okay. So by starting the leaf with this, for example, 2 sets of the algorithms, you could create quite beautiful drawings. If you check this meshes that you've done now, what you can do, you could, for example, just go to the top view, set up a light system, basic one in Rhino, and you will have a bit of a shade and render it. It will be a beautiful drawing already now. You could, for example, work in the combination, subdivide this, for example, mesh into the wireframe, bake the lines and overlap it with the edge trajectories, and you will have a beautiful drawing. So you will have quite a lot of possibilities to set up a drawing out of this instrument. And basically, I don't know if I have this open to my presentation. Yes, I do. So, and this is exactly the outcome of this type of work. Just by drawing the line, having a grid of points. You see here the grid, you set it up the grid, you have a point, you can make the point, you can assign a circle to the point and like extract a lot of information from this type of algorithm. Now you can increase the resolution of this algorithm maximum, and then you have quite a beautiful outcome for setting up a nice material. And I hope that this will be helpful for your next design project, and also that it will help you to proceed with experiments with the leaf. Think that this image that you were using now, maybe it's the mid step of your work. When you will have better image with a better quality and plug it there, I think you'll have even more amazing results. And you could then tomorrow with Vadim, you can take this mesh and plug it to the virtual room and start discovering this mesh with the different needs. And let's see what we have as an outcome from you. But these 3 steps of the experiment, I hope will give you a new tool for your design project and some instruments that you could be using further on. So what else I wanted to tell you? But, for tomorrow, we will check the work with everybody. But I just see that some people are disconnecting. That's why I wanted to say like there's some general information to everybody. So for tomorrow, and specifically for the final, I will ask everyone to document properly your experiment and to work on the visual language that you are setting up. So just creating a few slides, some catalogs, some final drawings, full screen, large, of your material experiment. Then come to the experiment that you've done now and show all the steps, all the iterations, document them, pre-render them. You don't need to spend much time with the rendering. We understand that this time is very limited now, and you can just pre-render, for example, some of your experiments in Rhino and show us some drawings with a line if you achieve to do the edge trajectory, and compile it also in a catalog, which will continue the catalog of the physical experiment through some digital iteration. And then you have already a nice collection of work that, after all, you will virtualize tomorrow. You will virtualize. And for the virtual reality, maybe you can take one iteration of your experiment from Grasshopper and just try with one. But maybe you have time to do more. I don't know. But they will help you. I'm sure it will be also easy. But yeah, keep trying. Check it, put things together, and I think it will be very, very beautiful, the work at the end. So, and now I want to check the rest of the team. Angel, do you have some cool results?
Thank you. I was taking notes, but I have an issue with installing Rhino, so I have to reinstall Rhino. But today I'm going to follow the exercise. Sure.
Okay, so if you have any questions, just drop a message and we check it together. And I just don't want to keep you abandoned with this work. If you have problems, please write me and we make it work. So Ramya, do you have anything done? You were silent today, but I hope that we had the chance to complete some beautiful work.
Yeah, I do actually. Sorry, I had network issues. I'll share my screen.
Super.
Yeah, I have this. Have this image. So this is final surface that I got. This is correct.
I think it's all is correct, but just here is exactly the problem of the resolution. First, for example, when you have at the beginning the grid, fact that your grid has the, yeah, here you have 70. Okay, go to, I don't know, 500. If you double click on the slider, to the B, no, double click to, oh, now I think it's not, it doesn't have 500 here, just double click on the B, on the slider, kind of,
All right.
like
I'll just
here.
add a new slider, I guess.
Oh, yeah, I'll do this, yeah. And you can exactly connect all to the new slider. And it will now drastically increase the resolution of your point cloud. This is first. And then when you have a scale, yeah, it will sync. So get ready. And
it's taking a bit of time. So
yeah, don't worry, let it run. And then when you control the vertical line, when you have a resolution, no, of this kind of vertical line on at the end of the definition, there maybe you also extrapolate it a bit more. No, you could go to 100, 150, and then you will have also a different resolution on the vertical axis. So, and I'm sure it will work because it's working perfectly. It's just about, it's a matter of the scale.
Got it.
Yeah, you see now, already now, like if you show it, I think it's beautiful. And kind of like, I would suggest you to check your experiments with a leaf, take different samples of the images that you're generating. See, like, okay, here don't go to 100, go to 50 maximum for you, I would say, because it will be enough. And then you will have a bit of the variety in the z-axis, and you maybe you want to increase even more the resolution of the grid, and then you'll have even more definition. See, like experiment, but basically it's working for you properly. Just maybe go to 50, 50.
Yeah.
So I think it's working. Yeah, quite beautiful.
Yeah, I guess there's no issues. All right, thank you.
Super. So I think we're good now. Okay, I was not checking the chat that much. Hassan sent us some beautiful results that we have done. Suggest you also check it. Beautiful. And I think that's the method which helps you to set up some beautiful digital drawings. And if you, for example, for the end of our workshop, you will document all this process through the few catalogs of the biological and digital experiments. And then you will have, for example, large, square, full-scale drawings, like full page. First, beautiful leaves. Think how you document the biological leaves. Then you represent it with a digital drawing that is done right now. Render it, check the color, how do you want to describe it? And then you dig into the virtual reality and drive us through the virtual experiment. That's, I think, a great result. Okay, so I hope everything was clear. I'm sorry for some problems with the connection in the beginning. I just didn't manage to use my microphone properly. So
That's
I
fine.
hope that you could follow up. Okay, and yeah, tomorrow Vadim will continue, and I hope you enjoy the day. I hope it was a bit useful and gave you some skills. It has been a great pleasure for me to work with you, with such an amazing and positive people from so many different places. Absolutely happy to share some knowledge with you. And I'm looking forward when we could maybe intersect in other reality, not only digital, but physical as well, and could work together on something else. And I could also maybe get some knowledge from you. Yeah, good luck with the next step. And I will see you at the final. So for today, it's good. And of course, if you have any questions, please write. And with both experiments, Laura will help you. If something not turning well and you want to know how to do it better, go for it. If Grasshopper again starts to give you bugs, yeah, just let us know and we solve it. Cool. So have a lovely evening, or maybe already morning in some countries. Say hi to everyone, and we talk soon.
Thank you.
Thank you.
Bye-bye.
Bye-bye.
Bye.
Have a nice evening. Bye.
Yes, well, thank you very much.